Rep 9. I'd like to say good morning, everyone. Thank you for attending today's workshop on future Keck infrared spectroscopy. Keck is a broad community, and it's a really fantastic facility, and it takes kind of all of us, I think, to get our heads together and figure out where we like to go. And thank you for participating and being part of that. So before we get into the meeting very much, I'd like to say there are 100 people registered for today's workshop. I see there are 37 so far. It's probably too many for introductions. I encourage people to use the chat if you want to say something to the group. That's fine. And then I'd like to thank Shelley Pelfrey for supporting us from WMKO. She's on, and she put together this list of Zoom etiquette, which you probably all understand. I would like to say that the meeting is being recorded now, and that's something that people asked for who couldn't participate. And I think it's also going to be useful in preparing the report for going back, seeing what really happened. And my understanding is we could make it available on the Keck YouTube channel, unless there are any objections. So I would also like to thank the invited speakers who all helped put the workshop together. This is not just one person. Then I'm going to move on here to start to get into the presentation here. And this is just a little bit of an intro about how this all came about, what the purpose is. I'm going to try to give some material on kind of the backdrop and context, but I think a lot of the value of this today is going to come out of our discussions. So I'm going to try to be quiet during some of this too, particularly during the afternoon. There's already some great discussion on Slack. Encourage people to keep that up. But going back to how this all came about is that you may have noticed, and we on the Science Steering Committee also very much noticed, there have been a lot of great ideas for infrared spectroscopy concepts over the years. This has come up through the white paper process that WMKO has been doing. Mark Cass is going to tell us a little more about the white paper process. You're going to hear from all the current instrument concepts, these four there, high spec, LIGO, scales, Ignis, that are all in various stages of concept development and proposal preparation and submission. And so there's a lot of interest there. We know that getting these things built takes a lot of effort. You know, it's the sort of thing that...
My slides first, and then we can go from there. Let me see. Can you see the talk?
Yes, looks good.
Perfect. Okay, great. So, okay, go back. So I'm a planetary scientist. I'm a NASA Goddard Space Flight Center. And as Tom was talking about, the main idea of this, I'm also part of the Keck Science Steering Committee. And one of the challenges when we receive the white papers and we're trying to connect the instruments with the science case is that how well aligned we are with the long-term goal of Keck. And as you may guess, it gets very complicated and to have an idea. And that's one of the good things about what this workshop is, collects the knowledge about what are the big competitors, what are the things coming in the future. And so when we can make more strategic decisions about based on this. And I'm going to be talking about solar system, especially when you can see there are a lot of images here of the outer planets. So, and they're big, and typically they have bright moons next to them. So if bright moons are very helpful when you want to do adaptive optics because you can do tip tilt NGS on them. And when you want to do adaptive optics on a standard optic like this, you need always a tip tilt source, and that's also been a challenge. In the bottom there, in the bottom right, you can see here an image of Mars that we tried in 2009. We actually waited 2 years for a star to pass, bright star, bright enough that we can actually try to do tip tilt on the star. And we were all there in Keck trying to get that done. And all the Strehl information from Mars was too bright and didn't allow us to do tip tilt. So this is the best we can do. It was actually pretty good, but again, Mars doesn't have a bright moon next to it, so tip tilt becomes very tricky. But nevertheless, you can see this is the power of the imaging thing can do. And then let's go back to the instruments and some of the discussions here. So some of the main things that we wanted to address in this workshop are, first of all, what are the needs for solar system? Mainly spectral range, resolving power, imaging capabilities, field of view, those.
Is background. I'll try to not focus on that, about what the capabilities are at other observatories. That's here. That's important for looking at where we overlap. So I'll try to focus more here on so our strengths. So what are our strengths that we should exploit? Well, we're in the north, but at a low latitude, which is great. We can see a lot of the sky. As we all know, it's an exceptional site in terms of seeing, low water, dark. It's accessible. We can get big things up there. The facilities are fantastic. We have aperture supremacy now. Stealing this from quantum supremacy. We've got world-leading LGS AO, excellent AO overall, actually better than excellent. And a real strength of our community is we've got a combination of diversity of enough different sites doing things, along with some established labs and some really big infrastructure for doing instrumentation. And I think it's great. We have multiple institutions, primarily Caltech and UC, but also input from others as well. There's, and also, although we are sort of.
The second big question is the beginning of galaxies and the last big phase transition of the universe, when the universe goes from being neutral to ionized. And we all think that this was done by galaxies, but we don't really have proof of that because we haven't seen those galaxies responsible for reionization. Unfortunately, I think this is a problem that it will be very hard to tackle from Keck. I think this is a problem where probably JWST has a leg up. Here I show you two plots, one from Jung et al., where they spent up to 20 hours with MOSFire to get some detections. And this is the results from Charlotte Mason of a large survey with KMOS. They used hundreds of hours on KMOS and mostly got non-detections. So I think here we're really hitting the limit of what we can do from the ground. Maybe with GLAO and MOSFire, we can use narrower slits and improve the sensitivity. Or maybe with even higher multiplexing instruments, we can go for longer exposures. But I think this is an area where probably JWST has a leg up, just because of the advantages of being in space and the fact that you don't really need high angular resolution. Then this is a theorist's view of how a normal galaxy like the Milky Way forms. And you can see that there's something pretty extraordinary going on. So gas, this is a map of gas, and gas cools, gas falls into galaxies, and then occasionally there are these big explosions from supernova that drive these winds that push back this gas into the intergalactic medium. And this is, I would say is extraordinary that we can do this kind of simulations, but as an empirical science, we would like to see these things happen. Do they really happen in this way or not? And this is very hard to probe, partly because you need to probe the multi-phase ISM and the state of the gas and the temperature and the chemical composition, and also the kinematics at very high angular resolution. And so as a community, we've made big progress in the, let me see if I can stop this. Yes, we've made big progress in measuring integrated properties of galaxies at high redshift, which can be in turn used to measure properties like their chemical composition, star formation rate, gas density, temperature, and so on. And these are integrated properties, which are a great step forward. And thanks to MOSFire, people have been able.
You must have covered things so well. So I found it interesting that that you are thinking about something like an IR Phobos being able to look at many objects is very much in line. We talked about packing into the detector, exploiting a wide field of regards, to be able to get spectra. So looking forward to hearing more about that. So I'll stop rambling and move on to Mike Rich, who has his hand up. So please, Mike.
Yeah, I was just noting the future of MOSFire, are there any possible detector upgrades, related to JWST development that one could take advantage of conceivably? I imagine, having seen, how much Phobos is likely to cost, the IR Phobos sounds wonderful, but also really could be a cost leap that we might have trouble obtaining.
Yeah, I don't know, maybe someone else should address this.
Yeah, from the technology side, I think we've milked James Webb pretty well with the cryo slit unit. Oh, sorry, I had my video off. For the cryo slit unit in MOSFire, that really is, I think, our big advantage. And also with, lately all of our near infrared instruments have really benefited from the James Webb H2RG detector development. Man, we really don't want to use those microshutter arrays. Those have been pretty difficult to produce well. And they've also been sort of optimized for sort of finer scales than what we have with Webb. It turned out that cryo slit unit, just the. Does anybody want to see anything more about cases? Oh, Randy, do you have a question or?
I had a comment on the question on which instrument do you use for your science. It's quite a bit different than what the TACs are awarding for Keck. The most popular instrument is by far MOSFire of these instruments, and maybe that's